Hey, and welcome to our tutorials on algorithm. Today I will show you how to solve one of the top 100 questions in Leetcode called valid parentheses, which falls into category of strings. This question has been mostly asked by Amazon, but it also has been asked by various other companies like Adobe, Google, Bloomberg, and a few others like so. Our language of choice is going to be JavaScript, and we will explore a stack solution for solving this problem. So without further ado, let's dive in. Okay, let's go through the problem. Given a string S containing just the characters open parentheses, open braces, close braces, open bracket, and close bracket, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, every closed bracket has a corresponding opening bracket of the same type. Now it's time for examples. First example here, we have a simple pair of opening and closing parentheses, they match together, then return true. Second example, we have three separate pairs, each are opening and then closing respectively, then is also a valid string. But in last example, as you can see, we have an opening parentheses and a closing bracket, which they don't match together, so we might return false for this. Let's start to think how we can deal with this problem. Before we get into the solution, I want to remind you that this problem limits us to three types of brackets: parentheses, square brackets, and braces. For now, let's simplify the entire problem and let's only pick one of these and try to think about a solution. We will go with parentheses for now. Now I want you to think about an input string like this, something completely random. In order to know this is a valid string of parentheses, we need to somehow keep track of opening and closing parentheses. One simple way that comes in mind is we can have a simple counter variable like so, and then let that counter increment when we see an opening parentheses and decrement when we see a closing pair. By doing so, at the end, if the counter ends up becoming 0, means that it is a valid string, but if the counter is not 0, it would mean that we already have some opening or closing parentheses left to match with their counterpart. Now for this string here, if we continue iterating and start incrementing, decrementing our counter variable like so, we would see that this string has a correct pair of parentheses because we ended up in 0. Now let's think about a falsy version of this. What would happen if we had our string as long as this blue line here? If that was the case, then our counter would end up exactly in here at number 3, which is not 0. Now again, ending up in 0 matters to us because that is a silver bullet for us to determine if we had a valid version of pairs or not. Now let's escalate this situation here. Let's add some spices to it. Let's imagine a case like this. Now we have two concerns in this special case. First is, it is obviously a falsy string. The opening braces does not close at the end. Second, we need to take care of three different types of brackets here. So the basic idea in previous one was having a counter variable and then incrementing or decrementing it. Now we need to do kind of same thing here, but with a different strategy. Instead of having a counter variable, since we are dealing with different type of brackets, what if we keep track of all opening brackets of any type, and as we move forward in our string, as soon as we saw a closing pair, we ignore them. At that step, the only way that this string could be counted as a valid string will be that we already close all the opening ones. I mean, opening parentheses could not be paired with closing bracket. Another example, opening braces could not be paired with closing parentheses, or opening brackets could not be paired with closing braces. These are all wrong pairs that we want to avoid them. Now think about this. What if as we go forward in our iteration and as we close some brackets, we actually somehow get rid of correct pairs and don't count them anymore? In this case, first one to eliminate would be this, second one will be this, third one will be the green parentheses, and now look what happened here. We have one left over. If there were some unclosed, they will definitely stay single at the end of our iteration like so. This may be a bit silly example, but let's think that this action of us is exactly like we are using a sieve, but with one condition, one big condition, that this sieve will only allow to pass the correct pairs that match up together. Now the only single braces will stick in sieve and will not pass through it. That is what exactly we want, sifting out correct pairs. Of course, this would be more obvious and understandable with an example, so let me show you how. Let's say if we iterate over our string, at the first index we will have one opening parenthesis parentheses. As promised, let's keep track of it. We will have some sort of storage like an array, let's call it my storage, which we will put our opening parentheses into it, like so. Next iteration, we have another opening brackets, again we will store it. Next one, now we have a closing brackets. I told you that we will remove it when we see corresponding closing pairs. So this time, as we can see, that very last item in our array, I repeat, very last item will pair with what we have in our hands now. So they will pair and we will get rid of them both. Moving on, same thing will happen to the opening braces in here. First we will add, then seems like the next one pairs with very last item in our array. Then we will remove them from our array again. Now, as soon as we reach the next one, we see another closing parentheses, but this time it also pairs with what we have in our array, which is the very first thing that we stored in our array at the beginning of iteration, which means this closing will pair with the last one in the array and we will remove them both. Now, so far we don't have anything in our array, which means up until this step, everything was correct and paired correctly. But for last item in our string, since it is an opening braces, we will add it into our array. Okay. Now we have finished iteration over our string, but we have some stuff left in our storage array. Now the length of our array will be acting as our counter variable, and if it is 0, then it means we paired up correctly, and if it is not the case, then we have some single ones that did not get their pairs, so it is not valid. Now, one big and important note here. When we were checking for pairs, I was always mentioning very last item of our array. We were always adding to our array, technically to the end of our array, and always checking the very last item in our array. So we blindly put something inside of that array, and whenever we wanted to check, we were accessing the last item in there and ignoring everything else. Basically, the last item we were putting in our array was the first one that came out every time for checking. Last in, first out. This is called stack in computer science. Stack is always follows the last in first out principle. I know that we have used array here, and I have to tell you that if you want to implement a stack data structure, you have to do a lot of stuff. But popping from array and pushing into array gives us the same functionality as a stack in JavaScript. And you will see this usage of array in most of algorithms that rely on stacks, like this one that we are trying to solve. Now, enough of talking and theory, let's jump into the code. So here we are in Leetcode. First, we are going to define our array, which will again act like a stack. Const stack is going to be empty array. Then, since we need to keep track of all openings, we need to somehow know how to close them. So we will create a small key value map that keys are closing brackets and values will be the opening pairs for them. Something like const map is going to be an object of closing brace corresponds to opening brace, closing brackets corresponds to opening bracket, and closing parentheses corresponds to opening parentheses. Like that. So why we are doing this? Let's think that if we have an opening in our stack, in order to close that, as soon as we see a closing bracket in our string, we will check for its corresponding opening from our map. And since we can access the opening pairs by their closing counterparts from our map, if that opening value is equal to the last item in our stack, then we found a pair that needs to be removed or ignored. The trick here is that mapping closing brackets to opening counterparts to be able to find a pair. Next, definitely we will have our loop for let I equal 0, I less than str.length, I plus plus. Now, inside of this loop, we will add values one by one into our stack. Stack.push str at index I. But with one condition of, before adding it into stack, we need to check if we already have a closing pair for it. Because if we have, we need to get rid of them both. If I tell it in a simpler way, if we reach into a closing bracket of any type, we want to get its opening from our map. Then compare it with the last item in our stack. Because if they are equal, first we will pop the item in our stack and then we will continue in our iteration. Something like if string at index I from our map, which will result in opening value, is equal to the last item that we stored in our stack, which is also an opening value. If they are equal, then we need to get the last item from our stack. Otherwise, we need to add that value in iteration into our stack because it's an opening, it is not closing. So now you see that in else case we push into the array, and in our if check we pop from array. This is the core functionality of stack. But now if we do the last step and run our algorithm, this will fail because of our very first iteration. What happens in our first iteration is that we have an empty stack, and let's say in the other hand we have an opening bracket. Now both values are going to be undefined for our if check. Stack is empty at this step, and we don't have any key for openings in our map, as you can see in here. That means two undefineds will going to be equal to each other, and it will result in fall into the first if check, which again will result in missing to add our first opening bracket into our stack in order to keep track of all openings. Simply, that is enough to make this loop incorrect for the next iteration. So solution will be simply checking for our stack's length. We will do something like stack.length and rest of our check here. At the end, as I said in the slides, the stack being empty will going to be the silver bullet for us to determine if the string is valid or not. Because if after finishing our iteration there was some leftover in our stack, then that is not a valid string. So we are going to be returning a boolean checking if our stack's length is 0 or not. Something like return stack.length equal to 0. So if we run this, as you can see, all tests are passing, and if we submit, we are in a good shape in here as well. Now let's jump into time and space complexities. For time complexity, we are having a loop over our string, so it will be O of n time complexity, where n is the length of our string. For space complexity, we are pushing every character in our string into our stack array. So again, it will be O of n, where n is the length of our string. And with that, I can say thank you for watching, and please like, comment and subscribe to our channel for more videos like this. Finally, hope you enjoyed this video, and see you in the next one.